So I'm going to do just a quick overview of some of the new things we're doing. I'm going to go through some of the system design considerations for those of you that are thinking about a drip system that maybe aren't as familiar. So I'm going to do some introductions as well for our team, introduce where we work at and what we do. This is the most important team here that I come home to every day. So my wife's in the front. She does our marketing work. Ted is not in here right now, but he's around today. We've got in the group here, so Trent Strom covers the sales kind of for Kansas, western Iowa, western Missouri, eastern Nebraska. Jason Mashoff, who you'll be hearing from a little bit later, is walking around somewhere. So he's a recently hired agronomist. So we have Jason as a full-time agronomist. Miles Peterson, who you'll hear from after lunch, a part-time agronomist. He also farms in Nebraska. Buyer does our water quality and research. You'll be hearing from him right before lunch. We'll do some demonstrations of what we're doing with water quality. Ted's in the back there now. So Ted and I are partners in NutraDrip. Logan Metzger does a lot of our plumbing and fusing, filter stations, kind of our all-around handyman. And then my brother Galen in the red shirt there will be talking. We do a lot of the research on our own farm here, and you'll see some of that data that Galen's going to share after lunch. My dad, Doug, founded Grimm's Gardens, and he still helps us, does all of our farm shows and goes around and meets with growers. His wife, Miranda, helps with marketing as well. It's a family business, and Seth Miller, I didn't introduce him. Seth does our estimating. He's running the electric equipment here today. We've got about, I think, 40 people on our team right now, which is about 3 times more than it was 2 or 3 years ago, so it's growing. We have, I think, 6 salespeople. Wyatt Byers in northwest Iowa. Travis Roki is down by Joplin, Missouri. Trevor's Hastings, Nebraska. Taylor's in west central Minnesota. Chris is in the St. Louis area. He's having some health struggles right now. But we've got a really good team, and then we've got a full team of automation people that do startups, winterization, installations. We're just finishing an installation today up in north central Nebraska, and then they're chopping silage in Minnesota next week, and so we'll start in on our fall projects next week in Minnesota. So it doesn't seem like it slows down. This is where our installations have been at to date. So quite a few up and down the I-29 corridor out into Nebraska, and then a lot of other scattered places is where we've done work at. These greenhouse, for those of you that haven't been here before, the greenhouses, we used to raise hydroponic tomatoes. And when I was in high school, Dad, there's 5 of us boys. Ted and I do drip, Galen and Glenn farm, and Keith does pivots. So he had 5 boys to try to keep busy, and he was always looking for new ideas. So the greenhouses were built originally for hydroponic tomatoes. And in the hydroponic environment, you spoon feed all of the nutrients through the water. And so every week we would take a tissue sample, we'd send that to a lab, we'd get those results back, and we'd look at what do we need to change in the nutrient mix based on what that tissue sample said. I did that during high school. Eventually the flowers pushed the tomatoes out, and now we do flowers and landscaping. But that was always in my head. And so once we put in our first drip irrigation system, which we did in the fall of 2012 on a farm 2 miles north of here, it was an aha moment that this is a way to deliver not only water, it's not just an irrigation system, it's also a nutrient delivery system. So you're going to hear a lot today about not just the water aspect of it. The water's important. Tim covered that we've got to get the right balance of water in the soil. But more importantly, what about the nutrition side? We're going to share a lot about that. I'll just quickly cover some of the components of a drip irrigation system, how it's laid out, how it works. Obviously, we're going to start with some kind of a water supply, whether that be a well, a pond, a river. We work with all different kinds of water sources. We're doing some work with wastewater. We've got a system down here at Holton that takes water out of a slaughterhouse, and we take care of all their wastewater out of a slaughterhouse. Talking to some cities using municipal water. So lots of options when it comes to water. It's going to go through some kind of a filtration system. The primary one we're going to use is the sand media filter, which are those big round tanks that you see. And I'll describe in a little bit here how those work. But we're going to go through a filtration system. It's going to clean the water. We'll inject fertilizer is what this is showing, and then it's going to get distributed to the field, go into valves, and there'll be different zones. So every drip system has these common components to it that are common to every system. One of the reason we started installing drip on our own farm was for odd-shaped fields. That's the first thing that people come to us with. I've got an odd-shaped field. How do I irrigate it? This is a 200-acre project in Illinois that we've done here over the last 10 years. We did it in 2 different phases. But you can see it's really cut up. This is a 30-acre patch, I think, and this is 25. So a really cut up piece, but with drip you can cover all the acres no matter what the shape or size of the field is. Every field gets a design. So this is a drip design for that same project. It's hard to see there, but this would be that corner, that piece down in the corner. So basically we've got a water supply up here. It feeds down through this dotted line. This dotted line is our main line, and then it breaks it into zones. So every drip system is going to have zones, and the reason we do that is because we need to be able to control where the water's going, and we're going to water typically a third to a fourth of the field at a time. Sometimes we'll do up to a half of the field at a time. So basically, we'll water a block of zones here, then we'll move over and water another block, and then another block. And those will be set up on a controller where it's going to water maybe 8 hours, 8 hours, 8 hours, and it's going to come back and do that same thing every day. So it's just going to be in a cycle. So when Tim talked about touching that plant and watering every day, keeping that moisture content just perfect, that's how we do that, is through zones. The system has to be able to flush. So all of the hydraulics behind a drip irrigation system is to have the ability to clean it. We get asked a lot, how long does a drip irrigation system last? And the answer is, depends on your water quality and your maintenance. A properly maintained drip system with good water quality should last 25 plus years. We have a system in York, Nebraska that we do maintenance on that's 38 years old and it's still running. It's got good water, they take care of it, and the system continues to work. So flushing of the drip line, what that means is when we irrigate, the water's moving through those drip lines, and down here on the end of the field, so this water's going from right to left, at the far end of the field there's what's called a flush manifold. And that flush manifold is closed when we're irrigating. When we go to flush, we open up some quarter turn ball valves, and the velocity in the drip line needs to get to 1 foot per second to properly clean it. And so that flushing velocity is really important, and that's what the drip system is designed around. So you might look at this and think, why can't this all be one zone? The reason is because it wouldn't flush properly. So flushing for a drip system is the most important thing about the design and why the system is laid out the way it is. So flushing and keeping it clean is really important. Cortland's going to talk more about acid treatment and what we can do for water quality here after a little bit. The actual drip line itself is either going to be 5/8 or 7/8 in diameter, and then there's going to be an emitter, which this is a blown up version of the emitter, on the drip line that the water actually comes out of. So there's actually a little device that they extrude inside the drip line, and that's where the water comes out. We know at a certain pressure how much water is going to come out of every one of those emitters, and we can choose different sizes of emitters. So we can get an emitter that's a 0.1 gallon per hour, all the way up to a 0.62 gallons per hour out of every one of those little drippers. For corn and soybeans, this 0.1 gallon per hour is our typical go-to emitter. And there's quite a few hydraulic reasons behind that I won't go into, but there's been a lot of research done to choose which drip line is the best and which emitter is the best. And so we have some standards that we use, and this 0.1 is our standard. One of the questions we get a lot is, can this go on rolling topography, or does it have to be flat ground? So there's two different kinds of emitters. There's pressure compensated emitters, which is what we have displayed here, where every emitter has a pressure regulator built into it. So as you go up and down hills, it's going to put out the same amount of water at the top of the hill as it is the bottom of the hill. It's going to regulate inside that drip line with this little pressure regulator. And the difference is there's a silicone diaphragm that they manufacture that's inside that regulator, and so as the pressure on the backside of that diaphragm gets greater, it closes the opening and it restricts the amount of water that goes through. So if you remember on this flow chart, as the pressure increases, the flow increases. You go to a pressure compensated flow chart, once that pressure gets to about 6 to 8 psi, it's flat. So think about that as you go up and down hills, that pressure is going to change from the top to the bottom, but you're going to put out the same amount of water top and bottom of the hill. Drip irrigation is a scalable system. This is a 670 acre field in Iowa that we did the last phase on this spring. So it's not just for small patches. This system, the Des Moines River, is running right through these trees here. So we've got a 1,250 gallon a minute river pump, and then we've got a 1,700 gallon a minute well that sits right here, and we feed this entire patch off of 2 pumps. The grower had looked at putting pivots on. As you can see, they weren't able to cover near as many acres, and actually it was going to be less expensive to go with drip irrigation because of the way this field laid out, and we were able to cover all the acres. So lots of reasons to look at drip. This is that same field, that same design. So again, you can see I think we have 32 zones on this field. So lots of ways we can move water around and manage based on the zones and soil type and what they have going on for crop there. At the same time, we can do small fields. The first field we started with, I think, is 40 acres. This is a 40-acre patch here. This is a 250-acre tract here. And then this land down here came up for sale, and he said, hey, can I add on to my system? Sure enough, we just put a pipeline in through here, and now we added another, I think, 350 acres. So he's got a total of 600 acres being fed off of one well. This is down in southwest Missouri. The installation steps and the process we go through. So the first step is plowing in the drip line. Let me back up. There's one more step in front of that, and that's what we call pre-ripping. So it's basically going with an inline ripper in front of the plow on the same shank spacing, getting rid of rocks, getting rid of compaction. It basically makes the plowing of the drip line 10 times easier. We go through and pre-rip first, then we come in with the plow, and I think I've got a couple other pictures here. So we've got, I think, 4 different plows that we use. We typically bring the plow, ask the farmer to provide the tractor. It's basically a 3-point implement. Then there's a crew that rides on the back of there that changes out the spools and watches it and makes sure everything works like it's supposed to. I think we've got a video here, Seth, if you want to pull that up, of the plowing in action. It's a fairly simple process, but it's a lot of labor. We can typically plow anywhere from 30 to 50 acres a day, depending on the size of the tractor and the size of the crew and the size of the field we're working in. The row units on the plow, and this is one of the things this video does a really good job of, these row units each have a gauge wheel on them and hydraulic down pressure. And I think we're going to see here in a little bit, we're going to go through a ditch. As the ditch comes up through here, and so you'll see the row units on the plow roll down through that ditch to stay at the same depth all the way through. That's a really important feature. There's some companies out west in particular that have rigid plows. And we've gone in on several projects after they were done installing, and they had problems, and they got tape at 6 inches deep, and they got tape at 20 inches deep. So there you can see the plow ride down through that, each row unit, going down through just like a planter would. Once the drip line is plowed in, then we come in with another tractor and do what's called wheel packing. So that shank goes through, it opens that soil up, and we got to go back in there and close that soil around every one of those drip lines. And you can go back to the presentation, Seth. It's a tedious process, but it's something we can't skip. There's 2 reasons for it. Number one, if we leave that soil open, the mice crawl down in there and start chewing on it. And we've had problems on really tight soil. If that didn't get closed all the way, then we get a lot of mouse damage the first year or 2. The second reason is because if we leave that open, that soil, there'll be an air gap in there. And so as you start watering, the water doesn't disperse in the soil, it just fills that void up. So we need that soil back around that drip line to make sure that it can disperse in the soil like it's supposed to. While I'm talking about rodents, that is one of the things that we scout for before we put a drip system in. So if we go into a field and you've got bad ground squirrels or pocket gophers, those are going to need to be trapped and poisoned and killed first, because if we plow a drip system into there, they will chew on it. Most of the time when you get, I'd say if you take Highway 81 and come east of that, we don't struggle with rodents as much as we do west of there. So the drier the soil, the drier the climate, sandy soils, raising alfalfa, those are all things that we know have a higher propensity to have rodent problems. But that's definitely something that we look at. There will be a few leaks with a drip system. That's the thing you have to maintain on a drip system, is you will have to fix a few leaks. We have crews that do that. On average, we say 1 leak per 5 acres every year. Just plan on that. It's about $1.50 for a coupler to fix it. You dig down with a shovel and repair those. Again, we have crews that do that, so I don't want to scare you away with it, but I also don't want you to think there's no maintenance with a drip system. There will be a few leaks with it. So after we've plowed the drip line in, we come through with a trencher and cut a trench. So here we've plowed the drip line through, and then we actually come through and cut through the end of it. We do put a set of what we call headlands, so there's actually probably 4 or 5 tapes running along the edge here, so we water all the way to the edge, but we put the trench out in the field usually about 20 feet just because of the length of the tractor. You can't pull all the way to the edge of the field unless you have a field that we can go into your neighbor. So there you can see we're hooking each one of those drip lines up with a little gooseneck or riser, we call it. So we drill a hole in the pipe, and there's a riser that connects to every drip line. In this case, there's 2 pipes in the trench. The larger pipe that you see is what we call the main line, so it's going down to feed the next zone. So there'll be zone valves that control the different zones. So a lot of times the trenches will have 2 pipes on them. Filtration, which we already covered a little bit. This is the diagram that shows how the sand filters work. So the dirty water's coming in the top. It goes down through the bed of sand, and then what comes out the bottom is clean. The controller is measuring the pressure differential. So it's measuring pressure in and pressure out. When that differential gets to a set point of, say, 7 or 8 pounds, it triggers a backflush. That water goes backwards through the tanks, and it's a self-cleaning system. So it's not like you have to be there to babysit it. It's going to keep itself clean as you operate. That sand needs to be replaced every 5 to 10 years, depending on your water quality. These are those control valves I was mentioning. So the controller is tied to these valves, and so from our phone, we can control which zone is on or off. We set up a schedule similar to like a lawn irrigation system where it's going to cycle through the different zones and turn those on and off and water each zone the correct amount of water. We can also fertigate based on those zones. This is just an example of another drip design. So you can see anywhere where this dashed line is here, that's where we have 2 pipes in the trench. On the flush line, we just have 1 pipe. The flush valves are going to be clustered here. There's groups of 2 of them. So basically there's 2 flush valves per zone. These are the different zones. This is a 200-acre field just south of Sioux City, Iowa. Frequently asked questions, just hit these real quick. Depth of drip lines, so we're typically going 12 to 16 inches deep. Depending on your deepest tillage practice, we want to be 6 inches below where you're tilling. But we don't want to be deeper than 16. One of the things that we've learned is if we put drip line in at 18 or 20 or 22 inches, you're not going to be able to effectively water or fertigate up into the root zone. 12 to 14 is really where the sweet spot is. If you were just doing 6-inch deep tillage in a good soil and you said, what depth should I put it? I would say 12 inches. That's, to me, in my opinion, that's the sweet spot. Spacing between the drip line is anywhere from 30 inches to 60 inches, and that's going to be determined by your soil type. So a lighter soil, a really sandy soil, we're going to need to be 30-inch spacing. If you've got some heavy clay, 60-inch spacing works well. Obviously, there's an ROI component to that we'll walk through with you, and we can price different options. We either do 30, 40, or 60. I would say 80% of the systems we do now are 40-inch spacing. How much water do you need? 2 gallons per minute per acre is the minimum. That's the minimum number we want to see. So if you got a 100-acre field, 200 gallon a minute, we can make that work. Optimally, or the maximum, would be 5 gallon per minute per acre. 100-acre field, 500 gallon a minute. The difference between those is how you're going to manage it. If you have 500 gallon a minute on a 100-acre field, it's starting to get dry, you can turn the system on and put on a 1/4 inch a day, every day on that whole field. If you have 2 gallon per minute per acre, you've got to look at the forecast, you've got to look at your soil moisture probe, and you've got to start watering before it gets dry, because you can only put out 1/10 of an inch a day. So we can make any of those work, but just understand that we have to use the soil as a reservoir, keep that soil full, because we're going to get in that week or two where we're using a 1/4 inch every day for 2 or 3 weeks, and if you only put 1/10 of an inch out, eventually you're going to empty your soil reservoir. On the drip systems that we're pulling out of reservoirs, which we have here on this 100 acres around the farm, we typically size the reservoir to hold 6 inches of water for every acre we're trying to irrigate. That's a good number. I would say from here going east, from here west, you may want more than that in a reservoir, but we want 6 inches, be able to irrigate 1 inch 6 times a year, essentially. How long does it last? 25 plus years if it's properly maintained. Cost per acre, we're in that $1,800 to $2,500 an acre range right now with where prices are. Maintenance for a drip system, we're looking at spring startup. So basically we go out, start the system up, check for leaks before you plant, or for sure before the crop is canopied so we can see what's going on. There's a winterization step where we come in with a big air compressor and blow all the lines out, and then an acid flush, which is something we're going to do every 3 to 5 years, depending on how much you're irrigating and depending on your water quality. There's some places we have to do that every year. There's some water that's bad enough that has to be done continuously. So those are all things that Cortland helps guys with. And just, I shared the cost per acre, and everybody, $1,800 to $2,500 an acre. Obviously, it's a large investment, but what's the value of that, right? How does that pay back? And so I just threw up some data here from the Precision Planting. We did a large research project with them out in Pontiac, Illinois. This is on soybeans. So this is their yield advantage over dry land. Pretty good average of 23, 25 bushels per acre over dry land in Illinois. Obviously, the drier the climate, the lighter the soil, the greater that difference is going to be. This is on that same farm on corn. So their average somewhere in that, we typically say 60 to 80 bushel increase over dry land for drip irrigation. So you can see there's some swings in there, but on the average, we're in that 60 to 80. This is the Beck's farm out in Atlanta, Indiana. We put in a drip system for them. Sonny Beck came to Netafim and said, I want to grow 400 bushel corn before I die. And so you can see we put the drip system in the fall of 2017. First year in, they hit 383. And this was a high management farm already. So on dry land, they were hitting 300. Okay, so then they put drip in and started managing in-season nutrients through the root zone. And you can see they got up to 383. They had a weather event in 2019, and then they hit 406 their third year in. And they've plateaued at that 380. That's not an easy number to hit. We've been trying to get into that yield level here on our farm, which Galen will share some data on that. And that's a hard level. That 300 bushel plateau is a hard one to get up to, but it can be done. And so I want to just talk a little bit about some of the new things that we're trying to measure. And I think that's one of the keys as we think about what does it take to do this? How do you get there? And the first thing you have to do is you have to measure where you are. What are all the variables on your farm and in your field that give you the outcome that you get today? And so the different things that we're doing, probably the number one thing we're doing is weekly tissue sampling. Even if you're just thinking about drip, I would encourage you to start tissue sampling now while you're in dry land, because that helps us understand what's deficient in your system or what's out of balance. A lot of times we see that it's not necessarily a deficiency, but things are out of balance. Miles is going to talk about this after lunch. He's out in Nebraska, and I've never seen anybody with such a balanced tissue sample, and he's going to show you some of those. The balance is actually more important than the individual values. How uniform and balanced is that plant? The plants are just like you and I. They want a balanced meal. They want to be steady and stable. Sap analysis is something we've looked at in the past. We're starting to look a little harder at some in-field sap sampling. In-season soil analysis. For the first 5 or 6 years, we focused on just doing in-season tissue sampling. Now we've started doing in-season soil sampling at those same points that we were doing tissue sampling. It's another measurement point. We started to understand that the tissue sample was only a part of the piece. It was only part of the picture. But now when we start looking at what's in the soil, and then we look at, we've got plenty of potassium or we have plenty of phosphorus in our soil, but it's not getting in the tissue, then you start asking why. Why is that nutrient that's supposedly in my soil, why is it not getting in the tissue? And you start to discover some things why that might be. We've got a few new sensors, and I don't have them out here right now, but the Lab probe, I'll get that out after or during lunch maybe. It's a probe that you push in the ground, and it gives you an instant soil measurement. It uses a new technology called spectrometry that uses a light, and it basically is an in-field soil sensor that gives you a soil analysis on the fly. Tech is a similar technology that's doing the same thing with tissue. It's a little scanner, you put the leaf in, push a button, and it pulls up a result on your phone of what the tissue analysis is. I will say that in particular with the leaf tech, it's a new technology that's still very much in development. It's not a fully baked technology yet. Lab is probably a year or two ahead of them, and we have a little more confidence in that. Dissolved oxygen is something I want to talk about just a little bit. It's a new kind of nanobubbles. Maybe you've heard that term or read some articles on nanobubbles, but basically it's the idea of how do you get oxygen into the water. And so we just got a unit in just 2 days ago. It's a demo unit, and we're installing that up on our farm just 2 miles north of here. We haven't even turned it on yet. We hope to get some results yet this year on soybeans. We're going to be injecting oxygen into the water to increase the oxygen in the soil. And what they're saying is that the nutrients will be much more available to the plant. It will reduce compaction. There's all kinds of things that they're touting that it will do. So we're looking at lots of new technologies, try to figure out how do we measure things. One of the other things I want to talk about briefly, a year ago in 2022, we brought this nutrient sensor. So this is similar to a soil sensor that measures potassium and nitrate in the soil continuously. It's an ion sensor. There's two little sensors on the end of here that you can hardly see, but they're basically giving us an electric value that you can correlate to the nutrients in the soil. This is what the sensor looks like out in the field. There's not a lot to see. We installed it on our drip field just 2 miles north of here. But basically what it's doing is it's measuring potassium and nitrogen that is in the soil solution. And so it's giving you a constant reading of what's out there. I'll show you just a real quick summary of one of the things that we learned. So this is June 13th. This line right here is the nitrate sensor at 24 inches, okay? So one of the key takeaways that we learned right out of the gate was our nitrate at 24 inches continued to climb all through the season. It got higher and higher and higher. We're in a heavy clay soil. We use anhydrous in the fall. We strip tail anhydrous in the fall, and then we were spoon feeding nitrogen through the drip system. And so one of the first takeaways is if in a heavy clay soil our nitrate continued to climb through the growing season, why? And how does that impact nitrate levels in the soil and ultimately in the groundwater? One of the things that I think, especially for producers from Nebraska, is all of us probably in this room are going to real quickly be regulated on how much nitrogen we can apply. And tools like this, I think, will help us understand how inefficient we are today with our nitrogen. Because there will be a day when they tell you you can only apply 150 pounds no matter what, or 100 pounds. These are some things we're looking at. We were supposed to get 10 more sensors this year. We ordered them in February, and I still don't have them. They have to come across the ocean, and there's been all kinds of logistics issues. We will have them in time for next year, and so that's something that we're looking to learn a lot more about in how to better manage nitrogen and potassium. This is that CRISA lab that I was mentioning earlier, the soil analysis from the spectrometry probe. It gives you all your standard things you would see on a normal soil test, pH, organic matter, CEC, and it's doing it in about 10 seconds. So, an interesting tool. We'll learn more about that and share it as we learn it. This is a result off of the CRISA lab. The same thing that you see here. Here's our analysis for tissue. Again, it's an interesting tool. We've been ground truthing it. It's maybe not as accurate as I'd like to see. It's not as accurate as I'd like to see. I'll just say that. Jason's going to talk a little bit more about this, but Tim mentioned earlier about using satellites and imagery for management. This is a tool we started looking at this year. It's based in the Netherlands, and it is a thermal satellite that measures temperature every day. There's a lot of satellites out there that are measuring NDVI, crop health, those kind of things. This one is based on temperature. And to us, temperature is directly related to how moisture stressed a plant is. For an irrigator, temperature is like really important. We've used some tools in the past that Netafim helped us with a few years ago. One was called Smart Field, and it had an in-field sensor that measured the temperature of the plant every 15 minutes. Within 30 minutes of turning the drip system on, the temperature of the plant dropped. Like, we've researched that, and we know that irrigation directly impacts the leaf temperature of the plant. So this is basically a satellite that does it for you every day over your whole field. One of the things they do with their model then is they give you what's called a virtual soil moisture sensor. So this is similar to what Tim was showing on a regular soil moisture sensor. It's giving you a graph that says, here's my full point, here's where I'm starting to stress, is down here at this red line, and we want to stay up in the upper half or upper third. So we're evaluating this tool on about 15 different fields right now. I think it's something we will probably be looking at to roll out to our growers next year. But again, how do we better manage what's going on in the field? One of the things that it does is it gives you a daily, ET stands for evapotranspiration. It's basically how much water that plant is using and moving through its vascular system every single day. So you can see this goes all the way back to planting at April 23rd. By the middle of June, we were about 1/10 of an inch a day. And then we started by July, mid-July, we started getting up in some of these really high values. So here's a 4/10 of an inch a day, almost 5/10 of an inch there for a couple days around the 1st of August. Really interesting data that you can start seeing what is your ET in your field every single day. So that's all within that thermal tool. I wanted to touch just a little bit on some of the work we're doing with manure. I don't know how many livestock guys we have in here. I know we have a few. NetAFM in California has been doing a lot of work with dairies out there, taking their manure out of their dairy facilities, cleaning it to a point that they can run it through a drip system. So I just want to give you an update where we're at. We've been working on this, what's it been, 5 years. Todd Roke's with us here today. He's going to talk after lunch, and he's been doing this on his farm. Matter of fact, this is his lagoon right here. We've got 3 different things I'm going to show you. Outdoor lagoons are very simple for the most part. We can drop in what's just a regular river screen, which that's not a new technology, but what's different about it is they wrapped a 200 mesh screen around the outside of the river screen, and then there's jets on the inside that spray out just like a standard one, and the unit that we're using has a pump mounted on the river screen itself, so it's self-priming. One of the things that's challenging about any river screen is priming it, and so we decided, you know what, we don't want to have to prime manure, so we're going to put the pump out on the unit, and so they've got this self-priming unit. We put this in at Todd's Lagoon, what's it been, a month ago. Ran it for 8 days and pumped, what was it, how many gallons did we pump? Do you remember? 900,000, almost 1 million gallons over a 10-day period. 90,000, okay. So then we took it, so we did 90,000 at Todd's for the first, I think it was there for 4 or 5 days. See, I think this is a video here that'll run. So you can just see the jets right here that are spraying, so they keep that screen clean. It's got an electric motor on it that turns that screen. So then from Todd's place, we took it down to another hog lagoon down by Wichita. We pumped 400,000 gallons on this lagoon in about a 6-day period. Worked very similarly there. We actually got a little more capacity on this just because of the drip system, the way it was set up. Then we took it to a dairy lagoon out in Indiana. The dairy lagoon was really low, so we had to take the floats off to get it to sit low enough. The floats were holding it up. They only had 2.5 foot of liquid in the lagoon when we got there. But we pumped 600,000 gallons in 6 days on that dairy. Again, you can see how it works there. It's pretty simple. So that's outdoor. There was one dairy that we tried this on that had a different manure system that it did not work on. So I'm not going to say this works in every situation, but it works in most. The next option that we have is what's called a microfilter. And this is set up on a deep pit hog barn. And we're going to take it to a deep pit beef confinement barn here in a few weeks as well. So we got this running just actually in the last 2 days. We've gotten things perfected a little bit. And I think this is a video here as well. So the first step is we pump it out of the pit, and it goes through that screw press, and it has that dry solids that come out of the screw press. Then we're dumping it into a tank, and then from this tank, it goes into these 2 microfilters. These microfilters are basically drums that spin, and it throws the liquid out through the drum, and the clean product then drops into this tank, and then from that tank, it's going into a drip system. So it's a few pieces of equipment. As of this morning, they were running about 37 gallon a minute. Right there, they were running 47 gallon a minute. That was our goal, was to get somewhere between 30 and 40 gallon a minute, and they got it working this morning actually really well. Pretty excited to have that option. We were using this microfilter on some dairies as well. This is one of the sites we were running on a dairy. This is a new piece of equipment we brought in from Italy about 2 years ago, and it's been really, it's a low cost, I shouldn't say low cost, it's a reasonably priced piece of equipment that is simple to operate. It's got a reasonably low operating cost, and it does a really good job of taking out the really small particles out of manure, which has always been our challenge. We can take the big pieces out with a screw press, but the little particles have been a struggle for us, and this gets it clean enough. We're also doing some work, this is on a dairy up in Minnesota, where we're using a vibrating shaker. They cleaned 13 million gallons over the past 6 months with this, put it into a lagoon, and now we're irrigating with that 13 million gallons. I think over the past week to 8 days, we put on 360,000 gallons of that 13 million. They want us to pump about 2 to 3 million of it yet this fall. So again, another piece of equipment. So we have several different options of separation equipment. We're more than just irrigation. We're getting into manure equipment and starting to find options and pieces of equipment that will work with different setups. So if you have any more questions about that, it's going to be a big push for us to continue to develop that and perfect that process. We've had a lot of interest in using, you get rid of all the smell, all the runoff, you put your manure on during the season. There's just a lot of benefits to being able to do that through a drip system.